Okay, welcome to my video on arithmetic and geometric sequences. So after this lesson, you will be able to describe and represent arithmetic and geometric sequences using variable expressions. So what exactly is a sequence? A sequence is an ordered list of numbers. Each number in the sequence is called a term. Arithmetic sequence. Each term is found by adding the same number to the one before it. You might also hear people say add or subtract because you can actually add, well, you can add positives and you can add negatives. And when you add negatives, that's the same as subtracting a positive. So we have 3, 6, 9, 12. The next number is 15. So the sequence is formed by adding what number? 3. So we call 3 is called the common difference. Okay, and what common difference means is the number that you are adding each time. Okay, and you got to be adding the same number each time to be able to call it the common difference. So the variable expression, obviously, you see the word variable, so it has to have a variable in it. So the pattern is plus 3. So we say the variable expression is n plus 3. Okay, moving right along here. You see 25, 21, 17. The next number would be 13 because hopefully you notice that the numbers are going down by 4. So if they're going down by 4, this sequence is formed by adding -4. So the common difference says it's the number that you're adding each time. So we can't say subtract 4. We have to say that the common difference is actually -4 because it's going down by 4 each time. The variable expression, there are two ways to write this. We can say n plus -4, or we can say n minus 4. So let me put an or here. Okay. So to recap, we have arithmetic sequence is a sequence found by adding the same number to the one before it. So you're adding the same number each time. We can be adding positives, we can be adding negatives. We can also add fractions as well, or even decimals. Okay, now we're going to learn about the geometric sequence. Oops. Okay, so geometric is each term is found by multiplying the same number to the one before it. And sometimes you hear people say it's multiplying or dividing because when you're multiplying by a fraction, it can be considered division as well. So we have our pattern 1, 4, 16, 64. We're looking for, this one's a little tricky, 256. Because the sequence is formed by multiplying by 4. Okay, now 4 is the common ratio. And the definition of a common ratio is the number that you are multiplying. And when it's a division pattern, you're multiplying by a fraction. Okay. So this one, since the pattern is times 4, the variable expression, we got to multiply the variable by 4. So we're going to call this 4n. Okay, now we have, look at this sequence. We have 12, 6, 3. Okay, now it looks like the pattern is divide by 2. Okay, or we can say multiply by a half. So if we're taking half of each number, half of 12 is 6, half of 6 is 3, so half of 3 is 1.5. And since the definition of common ratio is the number that we're multiplying by, and the numbers are going down, I'm going to have a fraction here. So the fraction would be 1/2. Now the variable expression we can write as 1/2 n, or this is another way to write it, n divided by 2. Both are correct, but the one with the fraction is the one you're going to most likely see. Now, we've talked about, to recap geometric, each term is found by multiplying the same number to the one before it. And we said you can multiply by a number, you can multiply by a fraction, you can multiply by negatives, okay? And then we have the common ratio is the number that you are multiplying by. And if the numbers are going down, then you're multiplying by a fraction, okay? The numbers can actually go up as well and multiply by a fraction, but we won't see too many of those in the ones that we're going to do. Okay, so some sequences are neither geometric nor arithmetic. So we have this one, 200, 202, 206, 212. And hopefully you notice that this is going up by +2, +4, +6. So the next one, of course, is +8, which would give us 220. So it asks us to describe the sequence. So we can say we are adding the next consecutive even number. And consecutive means one after another. And I said consecutive even number because we want the next even number. Okay, so now let's try some examples on the back page. So turn your page. Okay, here it says, what is the 9th term of the arithmetic sequence? So we know arithmetic means adding, okay? So we know it's going to be an addition pattern. So we need to study the numbers, and we're looking for the 9th term. Now I see 1, 2, 3, 4. So I know I need to make 5, 6, 7, 8, and 9. Now, if we study the numbers, we have -1, 6. Okay, you might not see the pattern there, but when I look from 6 to 13, I can see that it's going up by 7, and 13 to 20 is also going up by 7. So I know the pattern is adding 7 each time. So if I add 7 to 20, I get 27. If I add 7 again, I get 34. If I add 7 again, I get 41. Add 7 again, I get 48. And add 7 again, I get, 55. Okay, let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is the 9th term. So I'm going to write it on the blank. It's 55. Okay, the next question says, name the 8th term in this geometric sequence. So I know geometric means multiplying, so I'm going to look for a multiplication pattern. And I'm going to look for the 8th term. So I have 1, 2, 3, 4. I need 5, 6, 7, 8. So how do I get from 1 to 2? With multiplication times 2. Is 2 times 2 4? It is. Is 4 times 2 8? It is. So I know the pattern is times 2. So 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. So I know that my 8th term here is 128. Okay. Now, moving on here. It says, what is the 9th term in this sequence? So It doesn't tell me arithmetic, doesn't tell me geometric, so that might tell me it may be a neither. Sometimes it could be arithmetic and geometric, they just don't tell you. So let's look at this. And I notice to get from here to here, it's plus 1. Oh, and before I do that, let's draw the blanks. 1, 2, 3, 4, 5. So I need 6, 7, 8, and 9. So we have plus 1, then we have plus 2, and we have plus 3, and we have plus 4. So the next one is going to be plus 5, and that of course would give me 16. And then we have plus 6, which would give me 22. And then we have plus 7, which would give me 29. And last, we've got plus 8, which would give me 37. So I'm going to circle this. This is my final response. And the ninth term is 37. Okay, moving right along here. Number 4, it says, what is the common difference for this sequence? So, we know that common difference is the number we are adding. So let's put an addition symbol here so we know what we're doing. And so we're looking for the number that we're adding each time. So let's see, -8 to -2. Well, I know the numbers are going up, and they go up by 6. And -2 to 4, it goes up by 6. And 4 to 10, it goes up by 6. So the number that I'm adding each time is 6. So the common difference is 6. Notice I didn't put plus 6 because the definition of common difference is the number that we are adding. So I just write the number. Okay, number 5. It says, what is the common ratio of this geometric sequence? So we're looking for the number that we are multiplying each time. Now, I notice the numbers are going down. So it's a division pattern, and when we have a division pattern, we know we're multiplying by a fraction. So let's try to figure out here what we are dividing by. So try to think of a number that we're dividing by here. And if you can't see that, then look here. This is a little bit easier. 16 divided by what is 4? If you said 4, you are correct. So the pattern all the way through is divided by 4. Okay, now, if we're dividing by 4, that's the same as multiplying by 1/4. So we're going to say that the common ratio is 1/4. Now notice I didn't write times because multiplication is in the definition. The common ratio says the number we are multiplying by, so I just write 1/4. Okay, number 6, this is what is the common difference for this sequence? So we know common difference is the number we are adding. And now look, the numbers are going down, -8, -10, -12, -14. They're getting smaller. So we've got to figure out what number we are adding here. So they're going down by 2, so we must be adding -2. And I'm going to put that in parentheses there. Add -2, add -2. So the common difference is -2. Now notice I didn't write plus -2, okay, because it's the number we are adding. Okay, so I just write -2. Now, number 7 says, what is the common ratio of this geometric sequence? Well, common ratio is the number we are multiplying by. Okay, and notice we've got 1, then -5, then 25, then -125. So let's ignore the negatives for a second and figure out, how do you get from 1 to 5? Times 5. How do you get from 5 to 25? Times 5. How do you get from 25 to 125? Times 5. Now, let's take a look at the negatives. So I know it's times 5, but how do I get from +1 to -5? Yes, that's correct. I'm going to multiply by -5. And then, of course, okay, so times -5. And let's see, is negative 5 times negative 5 positive 25? It is. And is positive 25 times negative 5 negative 125? It is. So the common ratio here is negative 5. Now notice I didn't write times because it's part of the definition. Common ratio says the number that we are multiplying by. Okay, so one more example to look at, number 8. It says name the next 3 terms and write the variable expression using n and tell whether the sequence is arithmetic or geometric. So I'm looking here, and if I'm thinking addition, I'd say plus 25, then plus 50, then plus 100. Okay, doesn't look like we're adding by the same number each time. Let's see if I can figure out a multiplication. So 25 times 2. So let's try times 2. It works here. 50 times 2 is 100. 100 times 2 is 200. So now I'm going to continue that pattern times 2, and that gives me 400. And then times 2, that gives me 800. And then times 2, that gives me 1,600. So now the variable expression is the number, what we're doing to the variable. So what's the pattern? Times 2. So the variable expression would be 2n. And if you have room, write it on the blank. I had to write it down here because I kind of ran out of room. And what type of sequence do you multiply by the same number each time? That is called the geometric sequence. Okay, so that concludes my video on arithmetic and geometric sequences. I hope that you can now complete the classwork and the homework. Have a great day.